Okay, chapter 6. Chapter 6 is basically the same as chapter 5, but it's a little bit more terms, but mostly that's it. And last time we talked about two segments connected together. At that time, we only had arrow that goes from here to there. And at this time, we have this term. It means somehow flow can start from here and go there, and then somehow using via some kind of circulation mode, and then they can come back. This kind of situation is a little bit more realistic, so we'll talk about that. But the principle, hello. Okay. When we have a situation like this, we want to understand what's going on, and based on that observation, we will try to develop equations. To be more specific, mass balance equations. Mass balance equations like this. And the basic principle to develop this kind of equation is, as I said before, it's the accounting process or counting process. And we'll count how many arrows are there. How many arrows are going to be coming in and going out. Coming in is gain, and going out is loss. Okay? Gain is plus, loss is minus. So we have gain, loss and loss. Gain, loss. Right? 3 gains, 2 losses. So it's that much simple. For this box, we'll try to count gain 1, 2. And we have 2 gains. Now 1, 2, 3, 3 losses. Right? So 2 gains, 3 losses. So we have 2 pluses and 3 minuses. Right? So now you develop the equation, and then the rest of the business is how to solve the systems of a differential equation. Right. And we can simplify the previous equation by dividing everything by 3. And so this right hand side, as you can see, these 2 terms are, in this case, considered to be constant. But many times, the upper stream area, the input may not be constant. But in this case, for the simplicity, we'll assume those as constant. So those can be. So what you see in here is everything divided by this V1. Okay? And then we have functions of C1 here and there, and function of C2 there. So right hand side we have a function of C1 and function of C2. So A11 can be some combination of Q1 to K3, something like that, right? Okay. And then the same principle can be applied to here. And if we can solve these systems of differential equation, then we can, if we can express this as a function of time, and then we can solve the C1 and C2. So in other words, let's see, I can find the stroke. If you have C and T, and if you can find some kind of curve for C1 and for C2, then it's going to be easy for us to calculate C1 at time certain T, and we can have C1 T star, right? And C2 T star, right? So if we have function like this, it's just a matter of just finding the t-axis and then try to find the matching y value or c value in this case for us. And before we go for the diagnostic, in other words, the function of time, and we will solve this for steady state. Steady state means if we have enough time, then what is C1 and C2? In other words, what is the C1 infinity and C2 infinity? If everything is keep feeling as it is, and then somehow they will reach kind of equilibrium, right? So steady state, it has a few different meanings. Concentration at infinite time, or concentration at equilibrium. If everything it reaches some kind of state that is steady or same or independent of time, then we can say it is steady state. So many times when we have steady state, we often have this kind of curve, and then we say, okay, this is the same. From here, the C T is the C infinity, which is C infinity right here, and or C steady state, and this is our steady state that we're looking for. Or sometimes we can have this kind of thing, and then from here to there, the concentration that is constant. So constant means that we differentiate here. I must have forgotten something. Anyway, in here, my C is constant. The differentiation of this one is 0 in here, and this one is right. So I want to know now what steady state means. So in here, if we have steady state, dc1 dt and dc2 dt both are becoming 0, right? Okay, so 0, 0 there. Then we can play with this. And in here, even though I had a minus and plus, and this 2 does not match at all. But let's say this one is just a simplification of this one, and then we'll just draw a line here, so we'll forget about that. And based on this, we can just say the 2-sort matrix is going to be cumbersome to carry minus signs here. So I just pursue everything as plus. Okay? So this and this, they are different. Okay? Right? So then if you are not in the class, and then later on if you see this slide and you try to find why this minus is plus, there is no reason. No reason. No connection at all. I just rewrote everything. So this one is a lot more simpler. Okay? A lot simpler. And in here, and if you want, calculate C1 and C2 is a matter of solving a measure. But in this 2x2 case, it's just 3 equations. It's a middle school mathematics, right? Okay, and I don't want to go through this one. In other words, I don't want to spend too much time of the method to solve this system, because this is already too much simple and you already know. But one of the better example to solve this one is we can re-express this one in terms of matrix form, like here. This is my augmented matrix. This is vector, and this is right-hand side vector. Okay, and we call this as determinant. When we calculate determinant, this is done like this. will multiply these two first of all, and then put in here, and then we will multiply these two and then put in here and say minus. So we know this function, we know this value, right? And then we bring this one to my denominator. And then for C1, using this matrix, I will place W and W2 here, right? And A12, A22 is there. And then we can calculate determinant by using the same method that used in here, okay? So we calculate this and minus this. We calculate this right here and minus this. So this is your C1, okay? And same for C2. C2 in here, we will replace A1 to A22, in other words, the second column with this right-hand side vector, and then do the same. Very easy. But for this 2 by 2, let's say 1, 2, C2, A22, 2, 1, C1, A22, C2, W2. This is not a big deal because it's very simple, right? And if we actually didn't have to use method like that and any other method either. But in this case, if you multiply A21, A11, right? A21, A11, we will get the same thing, right? And then if we multiply this, we have the term in here. This one becomes A11, C1, and A21, A11, A22, C2, W2, A21, A11, right? Okay? And if we use these two and then subtract, then we can cancel this one, right? So we can just have a function of C2 only in here if we subtract these two again, and then we can simply calculate C2, and then once we know C2, then we can just substitute back into the original equation and then calculate C1. For 2 by 2 matrix, this is easy. But if you have one more, let's say 1, 3, C1, and C3 actually, and then this, let's see if I have it here. And for 3 by 3 matrix, we need more time, right? We have to reduce this equation somehow like this. And we can use the same principle here. We can multiply A11, A21, and then make these two constants the same, and then subtract each other. And then we have two terms left. And then we have another thing that we can do. In here we can actually multiply A11 divided by A21, and then we can remove this term. And then we will be left with this 2. And then we can play with this 2 and then 2 remove one more. Right? Then we can have an upper triangular matrix. And once we have C3, then we calculate C3, and then once we have C3 and the C2, and then we have those 2 and then C1. So that's the basic principle of solving this equation. Okay? If you have a large system, and sometimes we can have more than 3, many times. Let's say if you're dealing with a big river, and then if you have so many hundreds, thousands of the segments, and then there's no way that we can solve this equation by hand. Even we need a very large piece of paper to write the equation down. That's not efficient. In that case, we have to use the power of computer. Okay? So we'll study about that this Wednesday. And then anyway, so we can apply the same Kramer's method that we just used. Wake up, wake up. Okay, we have just C1 and C2, C3 only, and C1 and C2, C3 are multiplied by constant. If we multiply, have multiplication of unknown, if we have C1 and C1 times C2, that's not linear. That's non-linear, okay? And only linear is you just have constant for, in front of your unknowns. Your unknowns are C1 and C2, C3 in this case, okay? That's linear. If you have combination of multiplication of division, then that's not linear. Okay. So, and to solve this equation, there are many already famous or known method, common method to solve this. Gauss elimination is the most common used method, and Gauss-Seidel, and Gauss-Jordan, and many others. Actually, if you study linear algebra in mathematics department, and they will teach you in many different cases and also many different methods. But basically they are the same, because what they are doing is, I want to calculate C1, C2, C3. That's it, right? And then all of them have to give you the same answer. If their answers are different, and then that's not the method. That's just maybe opinion, right? Okay. So many different methods, but they have to provide the same answer. Okay, and well, and then I had a matrix analysis term in this chapter, but I moved to chapter 7, so we'll talk about the detailed method in Wednesday. But in here, I will just move on according to this our text. And so far, we have talked about steady state, concentration at equilibrium, right? Or same concentration that is independent of time. And steady state case, we have to carry things like this. In other words, my dc/dt is not zero. It's something. It's changing. And then I have to somehow calculate or drive there's a solution. So if we go back to this original equation, in this case, for the simplicity, and the author of this book assumed this one as zero. So we have different situation, right? In here, all of a sudden we don't see W, okay? And if you didn't hear my class, then if you just find this slide, then you will say, what is going on, right? So in here, in this book, W term, they are gone. They don't have it. They simply assume that's zero. In reality, that cannot be zero. So you have to do something about that. But in here, we'll just talk about the method only. Okay? So we'll just try to increase our kind of rows or ways to solve the situation. So in here, and if I just move on, that can be, because this was the combination of C1 and C2. If we have these two at the same time, there is no way that we can solve this equation. Solve this equation means I want to express C1 as a function of time and C2 as a function of time. That's the solution. That's the final answer that I want to find. But in here, if we have both the terms together, no way. Okay. So in here, we just play with that. Because, sorry about this procedure. In here, we have DC1 and DC2. And eventually, we simplify or homogenize the equation as in the form of as a function of C1 only. In this case, we can solve it. Okay, for C2, we can do that too. What do we do? We just played with those two equations, and then somehow came up with this answer. And let's see if we have. Okay, I have it there. Okay, and before we go on, let me just finish top. And using these two equations and this simplification, what I want to do is I want to solve this for C1. And I also can solve this one for C2. What did I do? What can I do? And this very simple. Okay, I have d C1 dt plus, let's say I have alpha. I will have A, okay? And d, let me do this one. Okay. And in here, my A and B and C are constant, okay? And let's assume my C1t equals C0, C10 e to the kind of and if I differentiate this one once, then I can have things like this. If I differentiate this one twice, like that. So I have this one dt right here. This one is C10 e to the power of lambda t, and in here C10 lambda e to the power of lambda t as well. And this one is C10 lambda square and e to the power of lambda t. Okay. So what we have is A, B, C, right? And we can cancel C10. We can divide everything by C10, right? And also, we can divide everything by E lambda t. Okay? Then what we are left in here is A lambda square, B lambda plus C percent. Look familiar? And if you go back to your maybe at high school or middle school mathematics, then this is just the second order polynomial, right? So what is x in here? Minus b. Remember? Okay? The same thing. Same thing. Exactly the same. So, in here, I have A as 1. Okay? And is this right? because I have something different in here. And I have 2a minus b plus minus root b squared minus 4ac here. I think this one should be minus. Okay? But anyway, we know the method. So in this case, I have 2 lambda, which is lambda 1 and lambda 2. And you can say either one is your lambda. You can have plus is your lambda 1, minus lambda. But in general, we have a plus term is usually lambda 1, minus term is usually lambda 2. So you have 1 lambda, 2 lambda. Okay? So what did I do? I calculated my lambda here because I assumed my CT equals C10 E lambda T. I still don't know about C10, okay? Because I didn't have any information. So for now, this is just something that I don't know. But now I know lambda, but I have 2 lambdas. Lambda 1 is the answer. Lambda 2 is also the answer. If both are answers, and we'll just use them both of them. Okay? So maybe in this case, lambda 1t plus and this is s. Lambda 2t. I still don't know. I still don't know what those are. Okay? But at least I know my lambda 1 and lambda 2 are there. And this is called a principle of superposition. If you have solutions, more than one, if you have 2, linear combination of a solution is also the solution. Okay? Linear, what is linear? Something multiplied by constant. If we have combination of that, that's linear. Okay? You can have minus, plus, whatever. So, in this case, we now have 2 lambdas right there. And then also we can do the same for C2, right? So we can calculate the 2 lambdas over there. And probably at this time, you may not understand clearly what is going on. If this was original assumption, and what is this? What is this? Right? And what is the answer? What is the solution? If you put this back into this equation, if everything becomes 0, then that's your solution, right? That's one of the ways to check your answer. Okay? And we want to find out if that makes sense. Okay? And since we use this principle, this one must be satisfied with this condition. If we put this back into here, it's 0, because we did it, because it's like a circling, right? And then this is the same. If you have put this back into here, you will have 2 sets of form like this. And one is 0, the other is 0. And you will have 0 plus 0. You have to play with your hand. And now you're following everything with your eyes, but you have to play with your hand. So practice it, okay? Practice it. And I want you to solve these 2 and then come up with this answer. And then also, I want you to, we will have one C1 equation like this, C2 like that. You still don't know what those are. And then you need the boundary condition or initial condition to solve for that. Okay? Because those are 2 still unknowns. And then those unknowns, you have to provide the information. You have to somehow measure, or somebody has to give you, or somehow you have to do something about that. But at this time, we don't know simply, right? Good. That's okay. That's okay. So, and one question is, how did we come up with this kind of a situation? And then from here, how do we come up with this kind of situation? So now I think you understood this one easily because we just assumed this one is a function of kind of exponential function. If you have this kind of thing, only thing that you have to know is lambda. To calculate lambda, we did this and then substituted this information back into here, and then we used this kind of principle, right, to calculate 2 lambdas. Okay? And we have 2 lambdas, and if you have 2 answers, I said if you have more than one answer, each answer is answer, but the combination of those 2 must be answer. So to be general, we will carry both of them. Okay? Sometimes either of this one can be 0, but dependent on your boundary condition or initial condition. Okay? So but at this time, we don't know. We don't know. That's okay. So anyway, this is the general form of your equation for C1. And this is general form of equation for C2. Very much important. Very much important. This will be in your final exam, okay? Then you will wake up. What? Final exam? My grade. Oh my God. What did I do in this class? Anyway, very much important. So, very clear from here to there. Very clear from here to there. And then very clear from here to there now. But problem still. What in the world happened? So this equation can become like this. And next slide will tell you. So this one is original equation like that. And then we can just kind of wrestle together to cancel the effect and come up with this. Okay? For example, let's take a look at this one. Let's move everything to here. And then differentiate once again. Then this one becomes like this, and this one will become like that, because this one is moved to here, then A is minus, plus it becomes plus. This plus becomes minus, right? So now we have a little bit different form, but we still have C2. What I have tried to do is simplify this relationship and the function of C1 only and the function of C2 only. Okay? So that I can solve things like this. Okay? So far it's okay, right? And for this one, when this one is in here, if we leave this one and then move it to here, and then it just becomes like this. Okay? So A1 to C2 is this C1, D2, and A1, C1, like that. And then this C2, D2, dt is in here, this second equation. This C2, dt is this one, and then I want put this one. It's a little bit confusing to me as well. Okay, and then this one is here. Alright. Then this, if we divide this one one more time, then let me write it down. Just following everything with your eyes only can be confusing in this case. Okay? And dC1 dt plus A11 dC1 dt minus A12 dC2 dt, right? Okay, then I said my I want to have DC2 dt somehow in, okay, I'll do this. My second equation, in the first place, I had a 1, 2, C2 equals DC1 dt plus A11 C1. And if we divide this, differentiate one more time, right? So I have DC2 dt here, and then my A12 DC2 dt is going to be I have to be careful. I have to be careful. Okay? I have to be careful. Okay. This is very confusing all the time. And that's one thing. That's one thing. And my DC2 dt in this case is A21 C1, A22 C2. And if we multiply everything by A12 DC2 dt equals A12 A21 C1, A22 A12 A22 C2. Okay? Okay. And I want this one right here to simplify this one. And A1 to C2 is, and I will, let me write. This one right here is, and we can have A22, A22. So what we can do in here is we will replace this whole thing by using C1. So DC2 dt right here is like that. We still have C2, and my A1 to C2 can be replaced with this one. So everything will become functional C1, right? So we still have a C2, and this one A1 to this C2 was this DC2 dt, and it's going to be like this, and this one came from here, okay? And then we still had C2, and this C2 was C2 was replaced by this one, okay? So you will know once you play with this, and then we can just rearrange every equation like that, and then we can come up with this C1. And we can do the same for C2. And as I said, by just following with your eyes, it's a little bit confusing, but you have to do it on your own. Okay? So what did I do? I just explained how are you going to come up with this kind of relationship. To do that, we just play with both equations, and then we are here now, and then by using this assumption and differentiation, we substitute those back into here to calculate lambda, okay? Lambda 1, lambda 2. So we have lambda 1, lambda 2, and in this case, plus and minus sign is a little bit confusing, but if you carry the minus and then you have to carry it, and in this case I did not have plus, that doesn't really matter. If you, as long as you keep consistency, and it should be okay. So, and then if I have, if I substitute everything back to here, and then I can have this one. In this case, I have minus sign. Oh, that's why I have plus here. In this case, I assume y lambda as I have different assumption minus lambda t. So that's why in this equation I have a minus sign. So in this case, I have a minus term, but in here I have plus. So as long as you keep consistency, it's fine. Okay. So this is again in the denominator 2a minus b plus minus root b square minus 4ac. We have the same rule. So we have c1 and c2, and then this one it doesn't it's so in this case we can if we have some more information, we can calculate C1, 0, C2, 0. In other words, in here, if we have T at 0, that's your initial concentration, the C1, 0. T, if T equals 0, then that's the C2, 0. And if we have 0 term, the power of real number is just 1 and 1, 1, 1, right? Okay? So we have this thing, these two are number values of C10, and these two, addition of these two is value of addition of C2. And for the boundary condition, usually that's you can have dependent on your information. If you have some information about differentiation at time 0, then you can use that information as well. Okay? Because this 1 dt is like that, this 2 is like that. And yeah, you can do that. So if we have 0 situation, if this is 0, this 0, 0, 0, then everything becomes 1 and will become like that. So, but in this case, we still have, we have 4 unknowns, and to calculate 4 unknowns, you need 4 equations. To calculate 2 unknowns, you need 2 equations, right? That's the worldwide, historically, right, truth. So far, we do not have enough information to solve for this, but this one it shows the kind of method to deal with this situation. Okay? Alright. So far, and then I want to summarize my today's lecture. Homework that you need to do by this Wednesday. You have to play with these two and come up with this equation, in other words, this equation and that equation. Okay? Let's assume, like in here, let's use minus lambda, because I use plus lambda, and then that is can be confusing to you. And in this case, if you use minus lambda t, C10, C20, whatever, and then you can have same answer that way. I want you to show this procedure, and then once you have this like that, I want you to put this back into this equation and show me these two can become 0. Okay? That has to be true, okay?